Okay, so today we're going to be continuing with our lesson on multiplying decimals. This is the second part, so it's multiplying decimals times decimals. Going along still with our Common Core State Standard 5 NBT 7, add, subtract, multiply, and divide decimals to the hundredths. So as I said, we're doing decimal numbers by other decimal numbers. So in this today, we've got two numbers that both contain a decimal, whereas before, only one of the numbers in our problem contained a decimal point. When we were multiplying whole numbers times decimals, we did get to the point where we realized that the decimal point did not affect the number part when it came to the multiplication. So I could go ahead and take this first problem and just ignore the decimals altogether and just do 81 times 37. Okay? So 7 times 1 is 7. 7 times 8 is 56. Put my 0 down to keep the place. 3 times 1 is 3, and 3 times 8 is 24. Add my two partial products together. I have 7, 6 and 3 is 9, 5 and 4 is also 9, and then the 2. So I know the number part of my answer is going to have 2997. So now I just have to figure out where do I put my decimal. When we were dealing with a whole number times a decimal, we could think about the repeated addition model to kind of line up the decimal point and drop it straight down. So if I know if I had a number that was in the tenths in my problem, then I needed to have tenths in my answer. Well, that's not going to work for us today because now both numbers have tenths. So we're taking one number time it's in the tenths place and we're multiplying it times another number in the tenths place. So let's think about this for just a minute. If I'd multiply a tenth times a tenth, what will I end up with? Well, if I know that 10 times 10 is 100, then 1/10 times 1/10 is 100th. So if I'm multiplying two numbers that both have tenths, that means my answer should be in the hundredths. So I need to put my decimal point in my answer so that it has hundredths. So that means I'm going to put my decimal point there, in between the two nines. A way that I can check to see if this is a reasonable answer is with estimation. 8 times 3 is 24. My answer of 29 and 97 hundredths is pretty close to 24. Whereas if I made a mistake and I thought, okay, here's both of these numbers end in tenths, so I have to put my decimal point here in between the 9 and the 7 instead, my answer would then read 299 and 7/10. Well, 299 is way off from 24. So that would be another way that I could verify, okay, I put my decimal point in the correct spot. Moving over to the second example, notice on this one I've got tenths times hundredths. So I'm going to have to do something a little different this one. Notice again that I've got two numbers here, neither of which have anything in the one spot. They both start out with zeros. So I can ignore those zeros when I set up my multiplication problem. And again, I'm going to reverse the order and put the 64 on top because it has more digits than the 3. And that'll make my multiplication easier. 4 times 3 is 12, carry the 1. 6 times 3 is 18, plus 1 is 19. So I know the number part of my answer is 192. And again, I've got to figure out where does my decimal point go. Well, if I look back at my problem, I've got tenths times hundredths. I'm going to use the same thinking that I did with my previous problem. If I multiplied 10 times 100, I get 1,000. So therefore, if I had a tenth times 100th, I would need 1,000th. Well, the thousandths place is the third place to the right of the decimal point. So I need 3 numbers behind my decimal point, which means my decimal point is going to go right there in front of the 1. Now that can look a little bit strange to some people, having a decimal point out in front with nothing there. So a lot of times we'll add that 0 in front of that decimal point just to make it look a little bit or so that it's easier to read this as 0 and 192 thousandths. Okay. Finally, if we look at our third example on this one, again here we've got a number that starts out with a 0, a decimal, and then another 0. The only number that I'm worried about in this problem is the 9. This factor, it has 1 and 7 hundredths, right? Now, this 7 is holding a place, or I'm sorry, the 0 is holding a place, so I can't ignore that 0 because it's holding that place. These two zeros, I don't need, it's not going to affect my multiplication. So when I rewrite my multiplication problem, I'm just going to write it as 107 times 9. So 7 times 9 is 63, carry 6. 0 times 9 is 0, plus 6 is 6. And 1 times 9 is 9. Again, it comes down to where is my decimal point going to go? Well, in this problem, I have hundredths times hundredths. Well, 100 times 100 is 10,000. 4 zeros, 10,000. Which means a hundredth times a hundredth is a 10,000th. Which is, again, 4 places behind the decimal point. Well, I only have 3 numbers. How am I going to put a decimal so that I have 4 numbers behind it? Well, the trick to that one is you're going to have to add a 0 in front of the 9, and then you can put your decimal point down. This 0 is fixed. It cannot be removed, otherwise it'll change the value of the number. If I had put my 0 on the end behind the 3, that 0 doesn't hold any value, and so therefore it would not be correct because I could remove it without changing the value of the answer. Again, if you're not comfortable with the decimal point being in the front, you can always put a 0 in front of it. So now I've got 963 10,000ths. Okay. So let's take a look at our what did you notice question. If we look back at our problems, in the first problem I had one number behind the decimal in both factors, tenths and tenths, and I ended up with 2 numbers behind the decimal in my product. Tenths times tenths is hundredths. In my second problem, I had tenths times hundredths, so 1 number in the first factor, 2 numbers in the second factor, and I ended up with 3 numbers, or thousandths, in my product. And then in the third example, I had 2 numbers, hundredths, 2 numbers behind the decimal in my first factor, and another 2 in the second factor, and I ended up with 4 numbers behind the decimal in my product. What does this mean? This means quite simply that all you have to do to figure out where your decimal point goes is count the number of numbers or the number of digits that are behind a decimal point in both factors and make sure that your decimal point goes in your product so that it has the same number of digits. So let's take a look at our notes. We're going to fill these in. To multiply decimals, the first thing we're going to do is ignore the decimal points. We don't have to line up the numbers by their decimal points when we multiply. And we're going to multiply the numbers as if they were whole numbers. Right? I do not want you to line up any numbers by the decimal points with this. And I don't want you to annex or add zeros to make them have the same number of digits. Those are strategies for adding and subtracting. These strategies are not necessary and will only make the multiplication more difficult for you. Don't do it. Don't line up the numbers when you multiply. Don't annex zeros. You ignore the decimal points and you multiply them like they're whole numbers. When you're done with your multiplication, you're going to count the total number of digits that are to the right of or behind the decimal point in both factors of the problem. Remember that the decimal point in a whole number is at the end, which means there's nothing behind it, no decimal places behind it. And we're going to put the decimal point in your answer so that there are the same number or amount of digits to the right as there are in the entire problem. And again, as we learned in that last example, we may need to add zeros to the left or in front of your answer to get the correct number of digits to the right of the decimal. Okay? So these are the examples I want you to copy into your notes. The first example is just going back to a decimal times a whole number. Notice there's no decimal in the number 32, which means it's at the end, and I don't have to worry about counting anything. So when I set this problem up, I would do 74 times 32. 2 times 4 is 8. 2 times 7 is 14. Drop my 0 as a placeholder. 3 times 4 is 12, carry 1. 3 times 7 is 22. Add my partial products, 8, 6, 3, and 2. And if I go back to my problem, in my entire problem, I only have 2 numbers that are behind a decimal point, so my decimal point's going to end up there, 23 and 68/100ths. In the second example, again, I've got 5 and 6/10ths and 2 and 8/10ths, but I'm going to ignore my decimals and just do 56 times 28. 8 times 6 is 48. 8 times 5 is 40, plus 4 is 44. Drop my 0. 2 times 6 is 12. Carry the 1, replace that 4. 2 times 5 is 10, plus 1 is 11. Add my partial products. I get 8, 6, 5, and 1. And again, I look at my entire problem. In my entire problem, I have one number here and one number here, making 2 numbers behind the decimal point. So my decimal is going to go right there in between the 5 and the 6. My answer should be 15 and 68/100ths. My third problem, I've got hundredths times tenths. Again, I'm going to ignore those leading zeros. They don't need to be there. And I'm going to ignore the decimal points and just do 55 times 9. 5 times 9 is 45. 5 times 9 is 45 again, plus the 4 I carried is 49. The multiplication part is done. Now I go back to my problem. I have 2 digits here and 1 digit here for a total of 3 digits that I need to be behind my decimal point, which means I have to put my decimal point up in the front. So I have 3 digits behind it. And again, I can put that 0 in front just so that it makes that decimal point stand out even more, looks a little bit better. In this problem here, the only numbers that I have to worry about multiplying are 8 and 4. These zeros in front aren't going to do any good for me. 8 times 4 is 32. That's the easy part. Now I look at my problem. I've got 4 numbers that are behind the decimal point in my whole problem. 1, 2, 3, 4. I need 4 numbers behind the decimal point in my answer. I only have 3 and the 2 so far, which means I'm going to have to add 2 zeros in front of that 3, and then I can put my decimal point down. So now I have 4 digits behind the decimal, and again, put that 0 up in front of the decimal. Okay? Okay, so go ahead and make sure you get these examples copied down and your notes filled out, and then continue with the rest of the lesson.